Welcome back to the Earth Science Classroom. Looking at tidal ranges today and looking at a global perspective. So, where are the highest tides, lowest tides, largest tidal ranges versus the smallest tidal ranges around the world, and the implications? So, this video is going to cover why there are different tidal ranges and link back to the other previous videos on tides that we did. Look at nodal points, looking at the different variables that could be in play based on each location that would control or dictate the ranges and tides. Look at areas around the world that have the highest ranges versus the lowest ranges, and obviously the implications to that. So, coastal management, environmental science, even looking into physical geography and landforms and how they can be adjusted or affected by this large or low tidal range, and how that would link up with various tropical cyclones and hurricanes and typhoons and even monsoons as well in certain parts of the world. All right, join me now. All right, so quick recap based on the other tide videos that we've produced in this series. And we're looking at the amphidromic point. Oh, there's an I there rather than O. There we are. Amphidromic point, also called the tide or tidal node, also called the nodal point. And it's a location in which there is oscillation around due to tidal forces. Basically, the ocean water is going to circulate and basically swash back and forward over these large ocean basins. And there's a point within the ocean basin where the water is going to move around, and at that point where the water's moving around, there is zero vertical movement. So there really is no real tidal range. There's no change in elevation of seawater because of the shape of the ocean basins, the seafloor topography, the coastal topography, the where the land is, and all these different variables create these points in the ocean. And these are called amphidromic points. And they're very important because the further away you are from this point, the larger the tidal range is going to be. And that's going to depend on the location. So I add these points into the world map, as you see here. Now, these X's, red X's, represent the amphidromic points. Okay, so you can see they're dotted around. They're kind of, some are more randomly placed. They're not really consistent with, like, on the center of an ocean or always by a coastline. There's kind of a random pattern to this. That's based on purely a lot of variables and, how deep each ocean basin is, the size, the width, and the amount of continental shelf, and so forth. But if you're around in that area of the red X, you're going to experience basically zero tide, zero vertical change in sea level. And obviously, the further away you are from the X's, you're going to have, or based on some location, you're going to have the more likelihood, the greater chance of having a larger tidal range. So let's add in the two extremes. So the blue areas that I've shaded in on the world map, that is basically around the nodal points or amphidromic points, and they are basically areas of zero tidal range. The oscillation goes around that, so there's no real movement. So you can see certain areas like Mediterranean right here, okay, the Gulf of Mexico right here, some parts of the southern eastern Pacific right here. Looking at the Indian Ocean, there's a couple of 4 areas kind of around there, obviously around large areas around the Antarctic landmass as well, off the coast here, Western Australia right here, off the coast of Perth, and obviously large areas in the Pacific, in the Western Pacific, right here off the coast of Borneo and the Philippines, going up, stretching up towards Japan, and one large in more northern central Pacific Ocean there, and the Sea of Japan also has a little tidal range. So they are dotted around, and then in comparison, there are areas where there's very high tidal range. Now, some of them are located far away from the null point. For example, in the North Atlantic, you've got this two null points right here. And you've got the edges where there's large tidal ranges in northern Canada, through Greenland, up into the archipelago, and into the United Kingdom, into the Bay of Biscay, and then down through Portugal into northern Africa off the coast of Morocco. So again, based on the contours of the land and stuff, and the slope and gradient, you're going to get a large tidal range over here off the coast of northern Brazil here, and over in Central America and off the coast of Colombia, right here around the equator. And you do have these correlations, but off the coast of Madagascar here, you got a small null point here, but then in between Madagascar and the Strait of Madagascar and Eastern Africa, such as Tanzania, Mozambique, this area here got very large tidal range. So some areas are linked to the distance, but other areas just primarily are the characteristics of the land, the shape of the land, contour of the landmass, the seafloor topography, the gradient, and a whole host of other variables. So if you're going to basically color the whole map in, what you'd have is you'd have an area of slightly increased tidal range around the blue shade areas, and as it goes further away, you're going to start to get increased ranges up until the point where it hits the already highlighted red areas, and you get that consistent increase or decrease away from the amphidromic points. So implications. Obviously, a large tidal range would mean a very large intertidal zone, which would affect the ecosystem, affect the species, the amount of coastal erosion. If it's wave dominated plus tides, then you've got a very serious or more extreme coastline with high levels of wave erosion, hydraulic action, deposition, transportation, longshore drift, perhaps. Also, if you link up the weather patterns and prevailing winds, the latitude, where there's more of a area where there's less wind, like the doldrums or the horse latitudes, versus an area of higher winds, like the trade wind areas, latitudes. So you can also link up where there'll be tropical storms, cyclones, typhoons, hurricanes. You might have, a hurricane that starts off the coast of Africa right here in the Azores, and comes up here and turns around the high pressure, and then comes in towards United Kingdom and Iceland, dissipates a little bit, but also, look at the tide. So you correspond that incoming hurricane, let's say it's a category 1 or even downgraded storm, that gets to the UK or Europe, then you add in a large spring tide at the same time, then you're going to have a large amount of water being pushed towards the UK and France and northern Portugal. So if you correspond that at certain times of year, then the tidal ranges can really cause a large impact. Coastal erosion, damage to structures, evacuating people, and all that different variables. So in terms of high and low tides, we have to consider is the effect on the coastline, the effect on the beach erosion, and how we can manage that and understand that these ranges are going to be more consistent, and link it up to other natural disasters that could occur at the same time. Oh, thanks for watching, guys. Hope this helped with tidal ranges. And any comments, please leave them. We're happy to chat to you and respond to you on comments. And if you like to subscribe, that's great as well. And look forward to seeing you in the next video.